In robotics, the components you place next to each other are just as critical as the components themselves. Welcome back to True North Mechatronics. Today we're engineering the Citadel Roof Deck and the GY-271 Retaining Cap. The GY-271 is a compass module. The roof deck will complete the assembly of the vehicle Citadel and fully enclose the TitanBot's logic core, but we're doing it with a focus on electromagnetic interference. Underneath this deck sits our motor shield, pulsing high current PWM signals along its left and right edges. To protect our sensitive compass module from that magnetic noise, we are engineering a housing for the compass in the center of the deck to maximize physical isolation from those noisy motor wires. Design, engineer, deploy. Let's get to the CAD. Begin by creating a body and a new sketch, and we'll put that sketch on the XY plane. Then create a rectangle symmetric around the origin. We'll set the width of this to 100 millimeters, and we'll set the vertical height to 76 millimeters. Next, we're going to create 4 mounting holes. These mounting holes will attach to the bosses that we built into the Citadel door panels in an earlier video. We're going to take these top holes and make sure that they're symmetric with respect to the y-axis, and we'll do the same thing for the bottom mounting holes. We're also going to make sure that the left-hand holes are constrained vertically so that they are collinear with each other. And we're going to set the diameters of all these holes so that they're the same. Next, we'll set the diameter of these mounting holes to 2.8 millimeters. And now we need to constrain the relationship of these holes to our deck. So we're going to set a distance between these holes, 38 millimeters. We will set an offset distance from the bottom of the roof deck to 13 millimeters. And we'll set these holes so that they sit 7.5 millimeters in from the edge of the deck. Alright, so with that we have fully constrained the mounting holes on our roof deck, and we can close out of the Sketcher workbench. Let's pad this shape out to 3 millimeters. And we're going to add a wire access hole at the bottom of the roof deck. This will be for the wire bundle that connects to the compass module. Let's reference the bottom edge of the deck, and we're going to use the Create Arc by 3 Points tool. And we're going to create an arc on either side of the y-axis, and we'll make sure that the center point of this arc is coincident with the y-axis. And we'll make sure that it's also coincident with the bottom edge of our deck plate. We need to close this shape, so I'm just going to use the line tool and close off that arc. And now we're ready to pocket this shape. We also need to constrain its radius, so we'll constrain that to 3.5 millimeters. Sufficient for the wire bundle. Alright, so let's pocket this one through. And now we'll take and we will get to building that housing for the compass. We're going to use the rectangle tool, but this time we're going to build a frame. And it's not going to be symmetric around the origin, but it will be symmetric with respect to the y-axis. We're going to set the width of this frame to 2 millimeters. And then we're going to set the inside edge so that it's symmetric with respect to the y-axis. We'll set the length of that inside edge to 13.5 millimeters. And we'll set the right hand edge, the vertical length, to 14.5 millimeters. Finally, we're going to constrain it from an offset from the bottom of the deck. So we need to reference the bottom edge of the deck, and we'll constrain it to 23 millimeters away from the bottom edge. Alright, so we are ready to close out of the Sketcher workbench, and we're going to pad this frame shape out to 5.5 millimeters. These dimensions were picked because that is the size of the compass module that we're using. So if your compass module is different, then you're going to have to change the internal dimensions of the housing to match that module that you have. All right, now because we do not want to create a hard iron error for the compass to read by attaching the DuPont male pin connectors to this module, we're just going to run wires straight to the compass module. And those wires are going to protrude through the bottom of the module, so we need to create some relief at the bottom of this housing to accommodate the wire sticking through the bottom of the module and the solder holding them on. So we're going to create a sketch there, and we're going to reference the left and right edges of the housing that we're constructing. And using the rectangle tool, we're going to create a platform, an offset platform, that is 9.5 millimeters in length. And so that gives just enough room for the module to sit flat. All right, so I'm going to close out of that, and I'm going to pad that out to 1 millimeter. And that is going to nicely accommodate the compass module that we're using. Now, the next thing that we're going to do is create a chamfer on this top edge here. That chamfer will match the rake of the windshield. So right now, this square edge will not allow the windshield to sit flush against the fender frame rails that we created earlier. So let's create a chamfer there, and we're going to set the chamfer to 13.3 degrees. And we'd like this to be 3 millimeters in size, but Blender will not let us put in 3 millimeters, so we'll put it in 2.999 to get as close as we can. And then we can confirm that that chamfer gives us the slope on the front of this roof deck that we were looking for. The next thing that we're going to do is we're going to add some text to the top of the roof just to brand our TitanBot. And to do that, we are going to use the draft workbench. And in the draft workbench, we're going to select the top face of our roof deck. And we're going to go up to utilities, and we're going to say select plane. You can see that's put a grid on the top of the roof deck. Now we're going to create a shape string, and I'm using a Linux-based operating system, and FreeCAD does not allow me to see the font files. So I'm just going to go download a TrueType font file from the internet, and I know that the Ubuntu font file is open source and available, so when you click on that, it brings you to the webpage to download it. We're going to click on Get Font and download all. Now it does come in a zipped folder, so we're going to have to unzip that folder. And inside that zipped folder is going to be a series of TrueType font files. We're just going to use Ubuntu Regular. You're welcome to experiment with whatever you want. We're just going to grab the Ubuntu Regular and put it on the desktop. All right, so now we are going to be able to access that font file. So I'm going to click on Desktop, grab the Ubuntu font, and I'll be able to use that for creating text now. So the text that I want to put on the top is the name of the robot, TitanBot, and we can set the location by just clicking on the grid, but that's not where I want the text to sit. So I have already played around, and I've determined that I want to set the location of this text to -36.5 on my X, 20 on my Y. I leave it 3 on Z. That's its distance above the table. And I'm going to set the height of the font to 13 millimeters. Now when I do that, I get the font exactly where I had planned it out and where I wanted it. I want to create a second shape string though before I go any further, so I'm going to grab a second shape string. Again, Ubuntu and FreeCAD don't remember that font file was what I selected earlier, so I'm going to go back in and grab that same TrueType font file. The text that I want is version 2.4. That's the current version of the TitanBot that we're working on. And the location for this particular one is going to be at 18 for X, 10 for Y. We leave Z at 3, and the size of this is, or the height rather, is going to be 6 millimeters. Alright, so that creates my two pieces of text that I want to put on the top of the TitanBot. I would like to get rid of this grid though, so I'm going to click off the grid selector, and now I need to return back to the part design workbench. Click on the model tab to see our shape strings. Currently, these shape strings are not part of the body that we're working on, so we're going to left click and hold the shape string and drag it over top of the body and release it. And you'll see that the shape string changes its relative tabbed position with respect to the rest of the elements that we're working with. So I'm going to do that for both of them. So both of these shape strings are now part of the current active body. I'm going to pocket each one of these shape strings to create some embossed text. And of course, the default value of 5 millimeters when you create a pocket is going to push that text all the way through. I'm going to reduce that length of that pocket to 1 millimeter, and that will give me the embossed or inset text look that I was going for. Let's do the same for the other one. And now we have added text to the roof deck for the Citadel. All right, now we need to create a cap that will go over top of the housing that will retain the module inside of the housing. So we're going to begin by hiding the roof deck, and we're going to create a new body and a new sketch, which we will put on the XY axis. And we're going to create a rectangle. We'll make it symmetric around the origin. And we're going to set the width of this to 22 millimeters. We'll set the height of this to 23 millimeters. And we will now close out of the Sketch Workbench and pad this shape out to 2 millimeters. Next, we're going to add the sides of the cap. So create a sketch on one side. And we're going to reference the top and bottom edges of this cap lid. Create a rectangle that is coincident with the corner points of our box. And I'm going to create another rectangle inside, and we're going to make this internal rectangle also symmetric with respect to the origin. Now we're going to add some dimensions here. So the top edge is going to be 17.8 millimeters, and the right-hand edge will set to 18.8 millimeters. And now that cap is fully constrained. So we're going to pad that out to 5 millimeters. And now we need to add a hole in the cap for the module's wires to pass through. So I'm going to right-click on the inside of the cap there, and we're going to create a rectangle. This rectangle is going to sit 4.2 millimeters away from the edge of our cap. So we'll constrain that. This one here is going to be 4.2 millimeters in this direction. And we will use the same dimension in the horizontal direction. All right, and then we're going to set the length of this cap to 10 millimeters, the height of this cap to 4 millimeters, and now this wire access port is fully constrained. We will pocket this shape all the way through. And with that, we have completed both the Citadel Roof Deck and the retaining cap that will sit on top of the housing on the top of our deck. Let's just bring that into view here. Of course, we built them both on their face, so this one's going to be upside down. Let's see if we can just rotate it. There we are. Okay, so there's our two shapes. With the Citadel Roof Deck complete, our navigation hardware is officially isolated, protected, and strain relieved. By integrating a clearance pocket into the housing, we ensure the housing is a secure fit for the compass. As always, the production-ready CAD files for the Citadel Roof Deck and the retaining cap are live on the GitHub repository. Grab the master assembly and edit the tolerances of that friction fit on that lid for yourself. Coming up in part 15, we have to address the heat from the L29 3D chips that we just trapped inside the Citadel. We'll be engineering a modular active cooling duct that mounts to the rear deck to force high-velocity air directly over our motor drivers, while simultaneously supporting a mount for our Bluetooth comms. Chart your course, build your world. See you in the next build.